Today's lesson is powers of monomials. Lesson 4. We've looked at the quotient property. We've looked at the product of powers property. And now we're moving into powers of monomials. If you remember, a monomial can be a couple different things. A monomial can be a number. It can be a variable. It can be a combination of those. So it could be 2n. It could be -5. It could be -5xy. Okay, any of those can be monomials. So the first concept says power of a power. And I talked about this in lesson 1 or lesson 2, where I said the base is 5 and the exponent is 4. And together they make a power. And I said that some of you might have learned that another name for an exponent is a power. And here is where we really can take that into consideration, because that's something that we talk about now. So we're going to take this power, 5 to the 4th, and raise it to another power, or an exponent. Okay? So it says to find the power of a power, multiply the exponents. So this is important that you separate, understand, memorize that when I am multiplying powers with the same base, we add the exponents. When I am dividing powers with the same base, I subtract the exponents. Now we're moving into multiplying the exponents. Just like I did before, I'm disappointed that they don't write. Step 1 is keep the base. Step 2 is to multiply the exponents. Step 2, so we have 2 steps. When I'm raising a power to a power, I'm going to keep the base and I'm going to multiply the exponents. So here I have 5 squared to the 3rd power. 5 squared raised to the 3rd power. And it says just multiply the exponents, but I want to show you. So I have 5 squared, which looks like 5 times 5. But I have 3 groups of 5 times 5. 3 groups of 5 times 5, or 5 squared. That, in the end, gives me 6 5s, or 5 to the 6th power. Another thing that I like to do is, for the most part, multiplication is shown in math with parentheses. So I have my students do this, because I see the parentheses and I want them to remember that 2 times 3 is 6. Here's the other example that they show you. You can use the rule for finding the product of powers to discover another law of exponents for finding the power of a power. So again, I'm given 6 to the 4th power, all raised to the 5th power. So they're showing you exactly the way that I showed you. They're showing you exactly the way I'm showing you, is grouping them. All right, so when I'm grouping them, I have 6 to the 4th, but I have it 5 times. So here's once, twice, 3, 4, and 5. And we know by now that 6 to the 4th means 4 6s. So here's 4 6s, another 4, and I did that 5 times. Well, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. That's where I get my answer. And it says to you again, just like we looked at in the other examples, okay? It says, notice that the product, multiplication, of the original exponents, when I multiply 4 and 5, I get the final power of 20. Showing you a break it out example, like I said before. If you're in doubt, break it out, write it out. Simplify using the law of exponents. I have 8 to the 4th in parentheses, that's a power, and I'm raising it to another power. If I think of my rule, okay, I know that parentheses mean multiplication, but I have a power here, and I'm going to keep the base, and I'm going to multiply the exponents. 4 times 3 is 12. So my answer is 8 to the 12th power. 8 to the 12th power. Now, again, if I forget my rule, it's very easy to just write it out. 8 to the 4th means 8 times 8 times 8 times 8. And I need 3 groups of those. There's one group, here's my second group, and here's my third group. So how many 8s is that? Well, there's 4, 8, and 12. So my answer is 8 to the 12th power. Next one is k to the 7th power raised to the 5th power. K to the 7th power raised to the 5th power. Again, here I have a power raised to another power. Okay, the rule states that we keep the base and multiply the exponents. 7 times 5, good, is 35. So k to the 35th power. If I forget my rule, it doesn't matter how many k's I have to write. Okay, I can write it once, k to the 7th. 1, 2, 3, 4, 5, 6, 7. But I need 5 of those identical. So 1, 2, 3, 4, and 5. There's 7 k's. That would be 14. That would be 21. That would be 28. And this would be 35. That's where I get my k to the 35th power. You can show your work. You can break it out if you don't know your rules. Grab your workbook. The Got It questions. It says do these problems to find out. I have 2 to the 5th power raised to the 2nd power. Again, I see parentheses and I see exponents here. I'm going to put a times sign here. I keep my base, which is 2, and I multiply my exponents to get 10. 2 to the 10th power. W to the 4th raised to the 6th power. I see parentheses here. I'm going to put a times sign. I keep my base of W. 4 times 6 is 24. Here's a little bit different one. 3 squared raised to the 3rd raised to the 2nd power. Okay, so 3 squared looks like this. 3 squared. But I need 3 of those. There's 3 of them. But I need 2 of these groups. How many 3's do we have altogether? 2, 4, 6, 8, 10, 12. So let's see if our rule works. If I multiply all the exponents together, let's see what happens. 2 times 3 is 6, and 6 times 2 is 12. You can write it out, break it out like I say, or you can learn your rules. The next one says the power of a product. This is probably the more difficult lesson in this chapter. It says to find the power of a product. Product means we're multiplying things together. So to find the power of a product, find the power of each factor and multiply. Okay? So in this first example, I have 6x squared raised to the 3rd power. So the way that I do it is I just take my red pen and I separate my coefficient from my power. And then I'm going to do, just like I kind of do in distributive, 6 to the 3rd times x squared raised to the 3rd power. So I've got my 2 pieces broken up. I don't break it up quite the way they do here, but this works better for me. So I have 6 times 6 times 6, which is 216. And then I have raising a power to a power. Keep the base, multiply the exponent. If you try and do too much in your head, I've taught long enough, I guarantee you, you're going to lose it somewhere along the line. Here I have AB in parentheses, a product. There's my product. I'm multiplying 2 variables together, and we're finding the power of that. So again, I like to separate my terms, my pieces, and I say a to the m times b to the m. And that's exactly what they have there. 3a squared, all raised to the fifth power. So 3a squared, what they did here is a little bit different. They have the 3 in green, they have the a squared in blue, and they have the exponent of 5, raising it to the fifth power in red. Well, they're taking 3a squared and they're writing it out 5 times. Okay? 5 times. Now they're breaking it down and taking the 3 and putting it all together. All right? Associative property says I can group it any order that I want. Then they're taking the a out, a squared, 2, 3, 4, 5 of those, and they put 5 of those together. So now I have 3 to the fifth power, which is right here, and I have a squared, but I have it 5 times. So I'm going to multiply 2 times 5, which I get 10. And when I multiply out 3 times 3 times 3 times 3, I get 9 times 9, which is 81. And 81 times 3 is 243. Simplify using the laws of exponents. Please write all the steps down. 4p raised to the third power, all raised to the fourth power. Separate them. Separate the 4 and the p. We need to raise the 4 to the fourth power, and we need to raise the power p cubed to the fourth power as well. Write it out. Do not skip this step. This step to me is paramount, so important. 4 to the fourth power times p cubed, I'm going to put in parentheses, and I'm raising it to the fourth power. Oh yeah, I remember that. That's multiplication because there's parentheses. I need to evaluate my 4 times 4 times 4 times 4, and p to the 12th is just going to stay p to the 12th. That's 16 times 16, which is 256, p to the 12th power. 256, p to the 12th power. Next one, negative 2m to the 7th power, n to the 6th power raised to the 5th power. Negative 2, m to the 7th, n to the 6th. Look at my separation of numbers. Do not cram them together. These are being multiplied together, all right? And I'm going to multiply here. I'm actually going to wait to do that until the very end. I don't want to confuse you. So now I raise my negative 2 to the 5th power times. I raise my m to the 7th to the 5th power. I raise my n to the 6th to the 5th power. Now here's where I'll say I multiply, I multiply. Here there's no exponent. Okay, there's no exponent right here. So I have to evaluate what that is. It's negative 2, that's my base, and it's repeated factors 5 times. 1, 2, 3, 4, and 5. M to the 7th to the 5th power is m to the, good, 35th, times n to the, what's 6 times 5? Good, 30. No calculator, please. Negative 2 times negative 2 is 4, and 4 again, and times negative 2. That's 16 times negative 2, which gives us negative 32, m to the 35th, n to the 30th. There's my final answer. Next thing we're looking at is the goddess for this question, so go ahead and grab your workbook so that you can fill these in so you don't have to do it in class and you can follow along. I have product of powers here. So I have 8 squared times b to the 9th squared. That means multiply, 9 times 2 8 squared means 8 times 8, which is 64. B to the 9th to the 2nd is b to the 18th. Remember, that's two groups of 9 b's. Two groups of 9 b's. The next one, I have quite a few terms here, so I'm going to rewrite it. 6x to the 5th, y to the 11th, or pieces. They're not really terms. I call them pieces. 6 to the 4th, x to the 5th in parentheses to the 4th, y to the 11th in parentheses to the 4th. Strongly recommend that you do this step. Do not skip it. 6 to the 4th is 4 sixes, repeated multiplication. 6 times 6 is 36, and 6 times 6 is 36, so we'll figure that out in a minute. This here means multiply. That's x to the 5th, that's x times x times x times x times x, but it's 4 groups of that. And same thing over here. So I have x to the 5 times 4 is 20, and y, 11 times 4 is 44. So now all I have to calculate is 36 times 36, which is 1,296. Comma goes there. It's a number in the thousands. You use a comma. X to the 20th, y to the 44th. And the last one. Again, I have several pieces in here, so I want to rewrite it. Notice I separate them with a dot to show multiplication because I want to make sure I separate them. Negative 5 to the 3rd power times, in parentheses, w squared to the 3rd power times, in parentheses, z to the 8th to the 3rd power. This means multiply. This means multiply. This I don't have an exponent for, so we just have to calculate it. We have to evaluate it. Negative 5 times negative 5 times negative 5. Negative times negative is positive, and it would be positive 25. 5 quarters is $1.25, and a positive times a negative is a negative. 2 times 3, 6, and 8 times 3, good, 24. So your answer should be negative 125, w to the 6th, z to the 24th. The expectation is that that work is shown. It is not, oh, I did it in my head. The work needs to be there to be understood. Finally, it says a magazine offers a special service to its subscribers. If they scan this square logo on a smartphone, they can receive special offers from the magazine. They want to find the area of the logo. Now on your FSA, they're not going to give you the formula for area of a square, for area of anything. You have to know that area of a square or a rectangle is length times width. If I consider the fact that this is a square, okay, it means that all sides are, what's the word? Congruent. Okay, so if that side is 7a to the 4th b, then this side is 7a to the 4th b. So some people say that area of a square is length times width, but some people say that it's side squared because we're multiplying the same number by itself, so we really are indeed just squaring one of the sides. 7a to the 4th b squared. Separate it. Okay, not optional. Don't do it in your head. I don't want to see that as your teacher. The b has an understood exponent of 1 because there's 1 there. 7 squared times a to the 4th goes in parentheses and it's raised to the 2nd power. B to the 1st goes in parentheses and it's raised to the 2nd power. 7 squared means 7 times 7, which is 49. 4 times 2 is 8, and 1 times 2 is 2. Here's the thing. I'm not trying to make you do more work when I ask you to show this work, okay? I can't tell you how many kids will do 7 times 2 is 14. And sure, you're going to say, I'm not going to do that. I know that 7 squared is 7 times 7. But even the best students, when rushed, when in a hurry, will make that error. So even if you write it out 7 times 7, sometimes we still make that error. But as your teacher, I want you to make sure that you are writing it out. I want to see every step. Okay? So my answer would be 49 a to the 8th b squared. Okay, so the area of the logo, let's finish it up. The area of the logo is, it's a weird number, that's for sure, 49 a to the 8th power b squared. And I could, of course, finish it up and say units squared. All right, so units squared because it's area. So today we took our rules one step further and applied them within the product of powers rule. Okay, so there's more to understand here, there's more to memorize here, but you can still break it out to figure out what you are doing.